Hi, my name is Emmanuel Kalassi. I am a technical consultant at Hewlett-Packard Enterprise based at Customer Innovation Center in Geneva. The purpose for this video is to show you the deployment of standalone SQL Server 2019 instance into a Kubernetes cluster, using CSI Driver technology for persistent volume. What is the CSI Driver? The HPE CSI Driver is a multi-platform and multi-vendor driver. The Container Storage Interface (CSI) initiative started as a cross-technology concept between container orchestrators to solve the storage headache once and for all. The benefit of CSI is the complete autonomy for the storage vendor to innovate at their own pace, give the user choice and radically simplify operations of the storage subsystem integration. Another key aspect of CSI is that it is decoupled from core Kubernetes, as CSI is an extension of Kubernetes and again increases the rate of innovation. HPE has chosen to abstract the architecture even further by making the CSI driver multi-vendor capable, meaning that customers will be able to use the same driver with multiple HPE products. In this demo we are going to deploy the driver to utilize one HPE Nimble Storage array. We will deploy a SQL Server database using persistent volume, dynamically provisioned by CSI Driver. The HPE Nimble Storage and Red Hat servers were connected via an HPE Flex Fabric 5940 10 gigabits Ethernet switch. Before I show you the actual steps how to deploy a single SQL Server instance into a Kubernetes cluster, I want to talk in the first step about the reasons why should you deploy a single SQL Server instance into a Kubernetes clusters. One of the greatest things about Kubernetes is the possibility to perform upgrades and rollouts of software components in a coordinated, reliable way. If you have SQL Server running in a Kubernetes cluster, it is a very simple task to update SQL Server to a newer version. If something goes wrong, Kubernetes is able to perform an automatic rollback to the older version. Another big bonus point for running SQL Server in Kubernetes is the possibility to restart a pod, which hosts the SQL Server container, in an automatic way when the pod, or the Kubernetes node, crashes. So, looking at my nodes in the Kubernetes cluster here, I have one master node and two workers nodes. We utilize the CRD to be able to abstract information about node, such IQNs and what networks it is connected to. So, now looking the Nimble Storage configuration. It is a IQN for master node bundle. These are the IQNs for worker node Cabernet. These are the IQNs for worker node Sauvignon. We have created beforehand a folder called data. In this folder will be stored the volumes created. Okay, now we will configure the CSI driver in our environment. The HPE CSI Driver for Kubernetes is available on GitHub. All the instructions are currently available on how to deploy it on Kubernetes. First of all, we need one secret that point to the one array that we have in our environment. Backend parameter is IP management address for Nimble Storage, and set username and password parameters. You should now see the Nimble secret in the Kube system namespace. Now you need to deploy the CSI driver and sidecars for the relevant Kubernetes version. In this demos the drivers were deployed before. The CSI driver and CSP service are well deployed on the nodes. Now we need to create a storage class. The following file shows the YAML file that describes a custom storage class. What we are going to show here is storage class parameters. What we have done here is basically divided the section, the common, cloning, provisioning parameters, and also the import parameters. Okay, let us get back to Kubernetes and deploy our workload SQL Server. Now our storage class is being deployed. After we have created our custom storage class, we need to create a so-called persistent volume claim. With a persistent volume claim, a pod can request some persistent storage for a given storage class. The following YAML files show the definition of our persistent volume claim, where we request 50 GB of storage from the previous created storage class CICSC1. Our persistent volume claim is deployed. By now we have created the necessary storage infrastructure in our Kubernetes cluster. The next step is now to deploy SQL Server itself into our Kubernetes cluster. The following YAML file shows the necessary definition of the replica set that we create to be able to deploy SQL Server. As soon as you have executed this command, a lot of different things are happening in your Kubernetes cluster. A new pod gets instantiated by Kubernetes. The pod requests the persistent volume. The pod pulls the Docker image from the Microsoft Container Registry. Deploy a service for connection. The pod starts the Docker image. Now it is possible to connect to the SQL Server instance with the internal address. to connect from outside the Kubernetes cluster. We need an external IP address. We now have an external IP associated with our service MS-SQL. We now have an external IP associated with our service MS-SQL. Now from my workstation with Azure Data Studio I can connect to the SQL Server instance. Now we can create a database or restore a database. In the beginning of this video, I have talked about the various advantages running a single instance of SQL Server in a Kubernetes cluster. One of the advantages is that Kubernetes always makes sure through the replica set, that the requested amount of pods are always online, healthy, and available. When a pod crashes, Kubernetes automatically recreates the pod to recover a SQL Server instance, and connect to the persistent storage. As you can see, it's quite easy to set up and use HPE CSI Driver, but you need a HPE Nimble Storage array to actually provision resources. Currently this is just a beta. We expect to hit GA later in the fall. More platforms, protocols, and services should follow shortly. The final version will also include all the latest capabilities in the CSI specification. We will also be able to demonstrate the capability of doing online resize of any of the supported file systems. Thanks for watching.